Hello everybody, this is Mr. Yosef and we will continue our factoring marathon. But in addition to factoring, I'll also find the zeros for this one and go ahead and graph them. So when we look at this problem, I want you to notice that this is a standard form. So we will look at the leading coefficient, which is in the front, which is -1, so it's negative. And the highest degree is a 3, which is odd. So I know this is negative and odd. So I know in my head that this graph is going to look like down, up, psych. It is actually up, down. So what that means is as x approaches negative infinity, y approaches positive infinity. As x approaches infinity, y approaches negative infinity. You just have to refer to your chart and get comfortable with these. For our y-intercepts, don't forget you just substitute 0 for every x. But I hope that you see here that everything becomes 0 except the last number. So you end up just getting 54. So your y-intercept is 0, 54. And when you're sketching, I would just put it over here and just call it a day and call this 54. So we know our graph will start somewhere up here. And we know I'll end somewhere down here. And so the only part that's left to do is to actually factor it. So I'm going to write it decently big so we can actually see it. So what I want you to notice is, first of all, is this negative sign. I do not like this. It's just going to make factor by grouping a little bit more confusing. So what I'm going to try to do here is I'm going to try to get rid of that negative sign. And also another thing that you should notice is that every number is divisible by 2. So I can just factor out a -2. And I am left with -2 times what gives me -2x cubed. I hope that you see that's x cubed. -2 times what gives me -6x squared. I hope that you see that's 3x squared. -2 times what gives me positive 18x. I hope that you see that that's a -9x. Be really careful here because we need our signs to match up. -2 times -9x will give us positive 18x, and then -2 times -27 is going to give us our positive 54. So at this point, we have taken care of that -2. We now have a problem that looks like factor by grouping. So we're going to go ahead and set up the procedures for factor by grouping, which I like to group the first 2 terms together, leave the minus sign alone, and group the next 2 terms. And as we can see, we're going to get -2 on the outside. That's still there from my previous step. So when I look at this part, I know that they both have an x squared in common. So I'm going to go ahead and take that out. And I'm left with x plus 3. Leave my minus sign. And I'm going to factor out a 9. And I'm left with x plus 3. So if you're thinking, how did he just do that? Just remember, -9 times x is -9x, which is what we had over here. And -9 times positive 3 is a -27, which we had up there. From this step, I'll leave -2 alone again, and I will factor out what these two have in common, which is an x plus 3, and then copy what's left over, which is x squared minus 9. And if you do this math, this will take you back to this. And that's the beautiful thing about what we're doing here. We're not really actually changing the values here. We're just writing it in a different way. I hope that you notice that x squared minus 9 can be factored more. And we are left with, from here, x plus 3, x minus 3. And so this is our problem completely factored. And now I'm going to take each individual factor and set that equal to 0. That negative 2 does not matter. It does not have an impact on what my zeros are. And I hope that you see we have x equals negative 3, x equals negative 3, and x equals 3. So two of these repeat, and the word that we use to describe that is multiplicity, that these two repeating have a multiplicity of 2, so there's going to be a bounce when we do our graph. So I'm going to go back to my graph. I'm going to plot 1, 2, 3, 1, 2, negative 3. So I'm going to plot my points, and then I start from left to right, and I remember that at negative 3 there's going to be a bounce. So I go here, and I'm going to bounce off it to my y-intercept. Then I'm going to go here into my arrow. Once again, how high or how low your arrow is, if it's right beneath it or a little to the right, this is a rough sketch. It doesn't have to be perfect. But here you can see that we got our end behaviors correct. We showed the bounce, we showed our zeros, and we showed our y-intercept. And that is good enough here. So we have one more example here, and this has to deal with fractions. So once again, let's go ahead and take care of our end behavior, which we see a negative sign and a leading degree of 4. So I know this is negative and even. So it's down, down, or in formal terms, as x approaches negative infinity, y approaches negative infinity. As x approaches infinity, y approaches infinity. Next step is y-intercept. Recall that your y-intercept is when you substitute 0 for x. So I hope that you see in this problem, we will get 0, 0. But this next part is the part that we're waiting for, is how do we find the x-intercepts? How do we deal with this negative 1/4? So what I like to say about the negative 1/4 is, if you feel like you have a problem with it, let's try to take it out. And so when I look at all of these, I see that they all have an x in common. So I'm going to take an x out, but I'm going to take a chance and also take a 1/4 out. So if I can take a negative 1/4 out, not only am I taking out the fraction, I'm also taking out one variable to make the problem simpler. So here, negative 1/4 x times what will give me negative 1/4 x to the 4? Well, that's just x cubed. That's not bad. But this next one will take a little bit more thinking. Negative 1/4 x times what is going to give me negative x cubed. Remember that there's technically a 1 there. So negative 1/4 times what number gives me 1? I hope that you see that's a positive 4. So negative 1/4 times 4 gives you negative 1. So that's why I'm going to put a 4x squared. Negative 1/4 x times what gives me 4x squared? Well, I know for sure it has to be negative. And I know the number has to be bigger because I'm multiplying by a fraction. So I'm going to go ahead and I'm going to put a 16x here. Because if I do negative 16 times negative 1/4, I hope that you see that gives you a 4. And then negative 1/4 times what gives you 16? Well, once again, this also has to be a big number. So I'm going to say that this is 64. So I know I did that in my head, kind of did it pretty quickly, but you have a calculator, you can take a little bit more time to think about what numbers would work. And now I hope that you see that this is another factor by grouping problem. I'm going to take an x squared out. I'm left with x plus 4 minus 16 and 64. What do they both have in common? I hope that you see they both have a 16 in common, and you're left with x plus 4. I don't encourage shortcuts all the time. However, remember, if factor by grouping works, these two parentheses have to be the same. So that kind of gives you a hint on the right side what you should get there if you get stuck. Next step, I have a negative 1/4 x. I'm going to copy one of my yellow parentheses, and then I'm going to take what's on the outside and put them together, which is x squared minus 16. I hope that you realize that x squared minus 16 is also a difference of perfect squares, and that you will get x plus 4, x minus 4. And here we have 4 zeros. Do not discredit this x. This x counts, this x has feelings, it is x equals 0. The negative 1/4 does not have an effect. Then you have x plus 4 equals 0, x plus 4 equals 0, and then x minus 4 equals 0. Then you get negative 4, negative 4 again, and a positive 4. As we can see, these two repeat, so there's going to be a bounce, and we zoom out and look at what we have created. We know we got a 0, we got 1, 2, 3, we got a 4, 1, 2, 3, 4, negative 4. We know that we're going to start down and end up down. We know the only place where something special happens at negative 4. So when we get up to negative 4, we're going to bounce, go through our y-intercept and our x-intercept, and go to our next point, and voila, we get a beautiful even negative graph. And it actually turned out pretty nicely. No fractions, no square roots. We actually got whole numbers from this. I hope this helped, and look forward to making another video in the future.